I am Dr. Ananta AMB, Professor and Head of Civil Engineering Department, SVIT Bangalore. Today we will see one more problem on the lap joint. Design a lap joint between the two plates, each of width 120 mm. If thickness of one plate is 16 mm and other plate is 12 mm, the joint has to transfer a design load of 160 kN. The plates are Fe 410 grade. Use bearing type of bolt. See, here bolts are not given, load is given. We have to calculate the number of bolts and efficiency or the strength of the plate, efficiency of the joint. We have to calculate. So now here it is given. Use bearing type of the bolts. Any type of bolts diameter it is not given. Therefore, let us assume M16 bolts, means 16 mm dia bolts of grade 4.6 for the connection. Therefore, nominal diameter D equals here 16 mm. Therefore, diameter of the bolt hole is for 16 above it is, we have to add 2 mm, it is 18 mm. The bolt grade is 4.6. Therefore, ultimate strength of bolt equals 400 megapascal or Newton per millimeter square. Now, the ultimate tensile strength of the plate, it is given 410. Ultimate tensile strength of the plate, equals 410 Newton per millimeter square. Thickness of the plate is T equals thickness of plate. T is always we have to take the minimum thickness. One is 12, another 16 means we have to take 12 mm thickness plate. Then from page number page number 75 of IS 800, we can calculate shear strength and bearing strength of the bolt. After getting bolt value, we can calculate number of bolts required. In that, first we will calculate shear strength of the bolt. Shear strength of the bolt. From page 75 of IS 800 2007, we have VDSB equals FUB divided by √3 into gamma MB into NN into ANB plus NS into ASB. In the lap joint, always NS equal to 0, NN equal to 1 we are considering. Now here we have to consider NN equal to 1 at the root thread. A and B equals, we know 0.78 times gross area of the bolt, pi into diameter is now 16 mm, 16 square by 4, 0.78, 16 square by 4 is the gross diameter. Next, ASB, gross diameter of the bolt is pi into 16 square by 4, it is 16 mm, 16 square by 4. Now I am substituting NS equal to 0. Now I am substituting the values here. VDSB equals FUB is 400 divided by √3 into 1.25. NN is 1 into ANB is 0.78 into pi into 16 square by 4 plus 0 into pi into 16 square by 4. So this term becomes 0 because it is 0. Therefore, VDSB, we are getting the value of the shear strength of the bolt is, we are getting 28974 Newton, that is equal to 28.974 kilo Newton we calculated. shear strength of the bolt. Now we will calculate what is the bearing strength of the bolt. Bearing strength of the bolt. See, bearing strength of the bolt also, bearing strength of the bolt. Bearing strength of bolt. Bearing strength of bolt. So we have from page 75, again from page 75 of IS 800, VDPB equals 2.5 into KB into D into T into FU divided by 1.25. So KB is the minimum of following. We know KB is minimum of following KB is the minimum of following. So it is, one is E by 3D naught. E means edge distance. It is not given, means we have to calculate. Edge distance is 1.5 times diameter of the bolt hole. It is 1.5 times 18. It is, I am assuming it as E equal to 30 mm. 30 mm. 1.5 times, it comes nearly 27. We will take 30 mm. Pitch is, it is not given, therefore we can calculate. It is 2.5 times the diameter of the bolt, therefore 2.5 into 18, it comes 40 mm. Now pitch I am taking 40 mm, edge distance I am taking it as 30 mm. It is 30 by 3 into D naught is 18 mm, it comes 0.556. Similarly I am calculating second value, P by 3 D naught minus 0.25. Pitch we calculated P 40 mm, 40 by 3 into 18 minus 0.25, it comes nearly 0.491. 0.491. Now I am calculating third value, FUB by FU, it comes 400 by 410 of the plate, it gives 0.9756. Again fourth value is, it is 1. It is 1. Therefore we have to calculate minimum of these values. Minimum of these values. Therefore KB equals, it is minimum is 0.491 here. 0.491. I calculated the KB value. Now I am calculating the VDPB or bearing strength of the plate equals 2.5 into 0.491 into D is a 16 mm diameter of the bolt, T is minimum thickness of the plate 12 mm, then FU is for the plates 410 divided by 1.25. So that is equals gamma MA, we got 77,303.04 Newton, that is equal to 77.303 kilonewton. Therefore design strength of the bolt or bolt value equals minimum of these two values. One is 77, one is 28. Therefore it is 28.974 kilonewton. I calculated the bolt value. Now see, after calculating bolt value we can calculate number of bolts required for the connection. Therefore number of bolts required, number of bolts required for the connection, equals load divided by bolt value. Load is given 160 kilonewton. 160 divided by 28.974, it comes nearly 5.5. Say 6 bolts. We have to provide 6 bolts. Now I am arranging the 6 bolts for the connection. See, This is the lap joint. 6 bolts, 1, 2, 3, 4, 5, 6 bolts. So these are the bolt holes. These are the bolt holes. This is the section 1-1. We have to calculate strength of the check, strength of the plate also, because strength of the joint should be same, means strength of the bolt also should be same. Strength of the bolts and strength of the plate, minimum value will be the strength of the joint. Therefore this width is 120 mm. Thickness we know this is 12 mm. Minimum thickness we have to take for the calculations. Now I am checking the strength of the bolts, checking the strength of the plate. Check for strength of plate. Main plates, strength of plates. We have from page 32, page 32 of IS 800. TDN equals 0.9 into AN into FU divided by gamma M1. Gamma M1 is 1.25 only. Here AN is, see 3 bolt holes are there. AN equals, total is 120. 120 minus 3 into bolt hole is 18 mm into thickness is minimum 12 mm. Therefore TDN equals 0.9 into AN is 120 minus 3 into 18 into 12 into FU is 410 for the plates divided by 1.25. So this comes nearly strength of the plate 297.56 kilonewton. The plate is ready to take 297 kilonewton. The joint is therefore the load coming is 160 kilonewton. The load is 160 kilonewton on the joint. Load coming is 160 kilonewton on the joint, but the plate can take 197. Therefore it is safe, which is greater than 160 kilonewton. Hence safe. Hence safe.